Chapter 2, Section 2.1, I place a copy of these pages on Canvas. So I think best thing is for you to print a copy, and while you're watching the video, you should have a copy in front of you. The very first part of Section 2.1 is how to solve the equations. Solve the equation, let's say if I have 2 plus a number is equal to 8. Something very simple. 2 plus what number is 8? We all know the answer is 6. Now, in algebra, instead of the question mark, we just put the x or any other variable, x, n. So what we did in our head, we subtracted 2 from 8. So always think of the example that you know the answers, and then you learn the process. So the process is, how do I come up with a 6? Is I subtract 2 from 8. So when you solve the equations, and this is a first degree equation. First degree equations, first degree equation is when the power of x is 1. So to solve this, we need to subtract 2. Or if I want to isolate x, I need to have x by itself on one side. So that gives you the value of x equal to 6. So let's look at these problems. I have 2x equal to 12. Again, this is a simple problem because we know the answers. 2 multiplied by, when you don't see any plus or minus sign between these two, means it's multiplications. Like if I want to show 5 times 3 is 5 times 3. Or 5 plus 3, right? So if 3 is the x, then it's 5x and 5 plus x. What's the difference between these two? This one means you're adding, this is you're multiplying. I mean, normally we don't have to put that doubt here when you are dealing with the letters. So 2 times what number is 6? You know the answer is 6. 2 times 6 is 12. How do I come up with a 6? In case of multiplication, you divide both sides by a number sitting next to x. So x is 6. Another example, let's say I have minus 3x is equal to 15. Between 3 and x, do you see a plus or minus? No, so it's multiplications. Minus 3 times what number is 15? Again, to find x by itself or isolate x, you divide both sides by -3. So on this side, I have just x or 1x, and 15 divided by -3, if you use your calculator, is -5. But if I have minus 10x is equal to minus 20. Again, you divide both sides always by what number you sit next to x. So in that case, x or positive x is by itself, and here -20 divided by -10, when I use my calculator, is 2. What about minus x is equal to 10? You always want to have x, not the negative. Do I see any number here next to x? If you don't see any number, you could always put a 1. Because if the coefficient or number sitting to x is 1 or -1, we don't show that. So if you don't see any number, it's 1. So now what do I have? -1x is equal to 10. Divide both sides by -1. So x is -10, or you could just multiply both sides by that, okay? So you need to understand the difference between multiplication and addition and subtractions. Now here, I have -6. These are all solved equations. I want to divide both sides by -6 because I want to find x by itself and I want it to have positive. So see, that's how it's -7. Now, this is not multiplication anymore. This is addition. See, between x and 1.2, there is a sign. So I want to move -1.2 to the other side. So you just add 1.2 to both sides, and that gives you the x. You know, there are two ways to do the problem. Let's say I have a problem like this. Let me look at this example. X plus 4 is equal to 5, and x plus 4 equal to 5. I want to show you two ways to do the problems. One is you want to find x, so you want to move this +4 to the other side. So you put -4 and -4. So x is 1, right? Or the second method is anytime you want to move a number or variable from one side to the other side, you have to switch the sign. I want to collect all the numbers on this side. So I move +4 to the right side. Anytime you move a number from one side to the other side, you need to switch the sign. So x is 5 minus 4 is 1. Okay? So let's say here you have 2x plus 1 is equal 3x minus 5. I want to show you both methods. Now, I want to move one of these two. 2x and 3x. 3x is larger than 2x. Always try to collect the variables or number on the side that has a larger number, like 3x greater than 2x. Or like, let's say I have 3 apples and 2 apples. This is larger, right? So in that case, you need to move 2x to this side. So you put minus 2x here and minus 2x. Since we are collecting x on this side, then I have to bring -5 to that side. So I put a +5 here and +5. See, in that case, I have 6, and here I have x. Or you could do it this way. I want to move 2x from this side to that side. So +2, if you don't see any sign, means it's positive. +2x, when you switch to that side, is -2x. I have +1 here already. I want to put -5. I want to move -5 to that side. So -5 become +5. So what is it? 6 equal to x. See, there are two ways to do this kind of problems. And then I'll show you here. Before I start moving, on this side, I have 3x and -7x. That would become -4x. And here I have 2x and 2x is 4x, right? Then I want to move. Shall I move -4x to this side or 4x to that side? Look, 4x, +4x is larger than -4x. So move -4x to that side. So this -4x, when you move it to the right, is +4x. I already have -28. So I want to move +28 to this side. So that is -28, -56. Now, 8 multiplied by which number is 56? This is division now. See, because 8 and x is multiplications. Divide both sides by 8. So this problem has combination of addition, subtractions, and division. First, I need to distribute 6 into the parentheses. 6 times 6x is 36x. 6 times +6 is 36. This is distributions of the 6. Let me talk a little bit about distribution because this is in Math 50, and since you combine 50 and 60 into 1, let me go ahead and work on that. I want to multiply 2 times 3x. 2 times 3x is this, means this. You have 3x and 3x, which you know is 6x. So when you multiply numbers. 2 times 3 is 6, and you just write the x. Let's say you have here 5 times minus 3x. 5 times negative 3 is minus 15x. This is distribution. Now let's say you want to distribute minus 3 into 5x minus 7. Let's look at this example here. You distribute. First, negative 3 times 5x, just these two, is negative 15x. Then negative 3 times negative 7. Negative 3 times negative 7 is positive 21. This is distribution when you multiply. Okay? And that's what we are using here in these problems. And look at this one. I have to distribute negative 5. Negative 5 times 4 is negative 20y. Negative 5 times negative 4 is positive 20 minus y. I distribute negative 2. Negative 2 times what? Y. Is it y or 1y? The same thing. Negative 2 times 1y is negative 2y. Negative 2 times negative 2 is positive 4. And then on this side, I have minus 21. And now, which one is larger, minus 21 or minus 2? Because I need to move it to the side that is larger. You know, we have, if you have a straight line, which is a number line, let's say you have a straight line and the middle is 0, and numbers increase as you move to the right and decrease as you move to the left, goes all the way to positive infinity, and they call it number line. It's like a ruler, you know, start from one place is 0, goes to the right, adding, and go to the left is subtracting. You know how the numbers are increasing this way? Okay. So, like on the number line, I see that 1 is greater than, 1 is less than 3, correct? Because 3 is on this side and 1 is that. Now let's look at the negative number. Negative 4 and negative 1. Which one is larger? Negative 4 or negative 1? Negative 1 is on the right side. See how the number always increase on the number line when you go in this direction. When you go in this direction, number increase. Is minus 1 greater than minus 4? Yes. Minus 4 is less than minus 1. So in that case, when I see here minus 21y and minus 2y, minus 2 is larger than minus 21. So I move minus 21 to that side, it becomes positive. See, become positive. And then I already have 20, and I move positive 4 to this side, is negative 4. Now here is, you divide both sides to find your y value. When you're dealing with the fractions, look, one denominator is 6, 3, and 1, or 1 over 1. Let's say 1 over 1, okay? I multiply every term by 6. You put a 6 here, 6, 6, 6. By doing that, then 6 and 6 cancel. You have 6 and 3. 3 goes to 6 is 2. And see, in that case, I don't have denominator anymore. And now is the divisions. You need to do distribution. Look, 1.3 times 7 and 1.3 times minus x. Which one is larger, minus 1.3 and minus 1.1? Remember, minus 1.3, for instance, if this minus 1.3 is here, minus 1.1 is there. See, minus 1.1 is larger. So you need to bring this to that side to make it positive. And 5.5 move. Divide both sides by number, always sit next to x because you want to find x by itself. This rule that you have to move a term to the side that has a larger is very important when we teach you inequality when we get to that section. That's why it's kind of important to follow that rule here. We do the distribution. See, 3 times x is just 3x. See, what is 3 times 1x? 3 times 1 is 3x. So when you don't see any number, it means it's 1. Now, in case like this, I see 3x and 3x cancel, and you come up with something which is not true. 21 equals 7? No, 21 is not equal to 7. Then there is no solutions. Like here, this one, I have negative 9 and positive 1x, right? 1x is greater than minus 9. So I move this to that side. Now, on the right side is 0 and is 10. You always divide by what is sitting next to x, correct? Now, sometimes the students do not understand what is 0 divided by 10. Well, use your calculator. If you use your calculator and divide, calculator will give you 0. So 10 and 10 cancel. What is the x? 0. What if you have like something like this, 10 divided by 0? Use your calculator. 10 divided by 0, the calculator will give you error or undefined. It's like I give you an apple and I say, can you divide this apple by 0? You cannot do it, it's undefined. Very similar to that, you end up having 6 equal 12. You know that's not true. 17 equal 8, no. What about this one? You know, when I ask you to solve this problem, look, solve x plus 2 is equal to 8. When you solve this equation, you just say, okay, well, we subtract negative 2. X is 6. How do I know my answer is correct or not? You always check. How do I check? You take this 6 and you put in the original equations. 6 plus 2, is that 8? Yes. What if I give you a number like x equal minus 5? I said, can you check to see if this is the right answer? Is this solution to that equation? Is this the right answer to that? You always check. Oh, let me see. I put negative 5 here for x. No, it's negative 3. It's not 8. When you solve the equations, you have only one answer. There's only one number that satisfies, right? Well, let's look at this. Can you find a number that when I substitute for x, both sides are equal? Yes, x equal 3. Okay. Yes, you're right. Is this odd number? No, try x equal minus 7. That also works. Any number works here. Why? Because both sides are equal. But when we give you these problems, you don't see it like this in the beginning, because like here, you see both sides are the same. So it doesn't matter what the x is, both sides are always equal. But when you switch it like this, you just say, okay, you solve it. Say 2x minus 2x is 5 minus 5. 0 is equal to 0. When you see that, means there are all real solutions, means both sides are equal. Okay? When you see something which is true, 0 equal to 0, yes, then every single number you substitute always works. And let's look at this problem here. Look, right here, 6x minus 30 is 6x minus 30. Both sides are the same. So it doesn't matter what number you substitute for it. Both sides are always equal. In this case, you just say solution is all real number. Let's look at this one. I end up having 8x minus 12 equal 8x minus 12. See, both sides are equal, or 0 equal to 0. If everything cancels, the solution is our real number. So if you run into a situation like this, 0 equal to 0, or both sides equal, is our real solution. If you run into something like this, then there is no solution. So that would be end of section 2.1.